Hi, and welcome to Introduction to Gen AI. I mean, Generative AI. Don't know what that is? Then you are in the perfect place. I am Dwamjad and I am a Google developer, and it's my job to help developers learn how to use Google Cloud. In this course, I will teach you four things: how to define generative AI, explain how generative AI works, describe generative AI model types, describe generative AI applications. But let's not get swept away with all that yet. Let's start by defining what generative AI actually is. Generative AI is become a buzzword. But what is it? Generative AI is a type of artificial intelligence that can produce various types of content, including text, imaginary, audio, and synthetic data. But what is artificial intelligence? Since we are going to explore generative artificial intelligence, let's provide a bit of context. Two very common questions asked are: what is artificial intelligence and what is the difference between AI and machine learning? So these are the mostly asked questions. Let's get into it. So, one way to think about it is that AI is a discipline, like how physics is a discipline of science. AI is a branch of computer science that deals with the creation of intelligent agents and are systems that can reason, learn, and act autonomously. Are you with me so far? Essentially, AI has to do with the theory and methods to learn. Machines that think and act like humans. Pretty simple, right? Now, let's talk about machine learning. Machine learning is a subfield of AI. It is a program or system that trains a model from input data. The trained model can make useful predictions from new, never before seen data drawn from the same one used to train the model. This means that machine learning gives the computer the ability to learn without explicit programming. So, what do these machine learning models look like? Two of the most common classes of machine learning models are unsupervised and supervised ML models. The key difference between the two is that with supervised models, we have labels. Label data is the data that comes with a tag, like a name, a type, or a number. Unlabeled data is the data that comes with no tag. No. So, what can you do with supervised and unsupervised models? This graph is an example of the sort of problem that a supervised model might try to solve. For instance, let's say you are the owner of a restaurant. What type of food do they serve? Let's say it's pizza or dumplings. No, let's say pizza. Like, I like pizza. Anyway, you have historical data of the bill amount and how much different people tipped based on the order type, pickup, or delivery. In supervised learning, the model learns from past examples to predict future values. Here, the model uses the total bill amount data to predict the future tip amount based on whether an order was picked up or delivered. Also, people tip your delivery drivers. They work really hard. This is an example of the sort of problem that an unsupervised model might try to solve. Here, you want to look at tenure and income, and then group or cluster employees to see whether someone is on the fast track or not. Nice work, blue shirt. Unsupervised problems are all about discovery, about looking at the raw data and seeing if it naturally falls into groups or not. This is a good start, but let's go a little deeper to show this difference graphically because understanding these concepts is the foundation for your understanding of generative AI. In supervised learning, testing data values such as x are the model outputs a prediction and compares it to the training data used to train the model. If the predicted test data values and actual training data values are far apart, that is called the error. The model tries to reduce this error until the predicted and actual values are closer together. This is a classic optimization problem. So let's check in. So far, we have explored the differences between artificial intelligence and machine learning, and supervised and unsupervised learning. That's a good start. But what's next? Let's briefly explore where deep learning fits as a subset of machine learning methods. And then, I promise, we will start talking about generative AI. While machine learning is a broad field that encompasses many different techniques, deep learning is a type of machine learning that uses artificial neural networks, allowing them to process more complex patterns than machine learning. Artificial neural networks are inspired by the human brain. Pretty cool. Like your brain, they are made up of many interconnected nodes or neurons that can learn to perform tasks by processing data and making predictions. Deep learning models typically have many layers of neurons, which allows them to learn more complex patterns that traditional machine learning models. Neural networks can use both labeled and unlabeled data. This is called semi supervised learning. In semi supervised learning, a neural network is trained on a small amount of labeled data and a large amount of unlabeled data. The labeled data helps the neural network to learn the basic concepts of the tasks, while the unlabeled data helps the neural network to generalize to new examples. Now we finally get to where generative AI fits into this AI discipline. Gen AI is a subset of deep learning, which means it uses artificial neural networks, can process both labeled and unlabeled data using supervised, unsupervised, and semi supervised methods. Large language models are also a subset of deep learning. See, I told you I do bring it all back to Gen AI. Good job, me. Deep learning models, or machine learning models in general, can be divided into two types: generative AI or discriminative models. So basically, in these type of models, there is classification or predict labels for data points. In these type of models, they are typically trained on a data set of labeled data points, and they learn the relationship between the features of the data points and the labels. Once these models are fully trained, it can be used to predict the label for new data points. A generative model generates new data for instance based on a learned probability distribution of existing data. Generative models generate new content. Take this example like um, learn the conditional probability distribution or the probability of y. or output, given X or input, that this is a dog and classifies it as a dog and not a cat, which is great because I'm allergic to cats. The generative model learns the joint probability distribution or the probability of X and Y. And basically, it is the written as P into X comma Y and predicts the conditional probability that this is a dog and can then generate a picture of a dog. I am going to name him like Fred. To summarize, generative models can generate new data and other discriminative models between different kinds of data. For example, one more quick example like the top image shows a traditional machine learning model which attempts to learn the relationship between the data and the label or what you want to predict. The bottom image shows a generative AI model which attempts to learn patterns on content so that it can generate new content. So, what if someone challenges you to a game of it called as is it Gen AI or not? How will you figure it out? I have got your back. This illustration shows a good way to distinguish between what is Gen AI and what is not. It is not Gen AI when the output or Y or the label is a number or a class. For example, spam or not spam or a probability. It is Gen AI when the output is natural language like speech, text, audio, image like Fred from before and for example. Let's get a little matty to really show the difference. Realization this mathematical would look like something this which is shown on the screen. If you haven't seen this for a while, the y equal to f of x equation calculates the dependent output of a process given different inputs. The y stands for the model output. The f embodies the function used in the calculation or model, and the x represents the input or inputs used for the formula. As a reminder, inputs are the data like comma separated value files, text files, audio files, and other billion. It is not a gen AI. Like if y is a sentence, like define sales, it is generative AI, as the question would elicit a text response. The response would be based on all massive large data the model was already trained on. So, the traditional ML supervised learning process takes training code and label data to build a model. Depending on the use case or problem, the model can give you a prediction, classify something, or cluster something. Now let's check out how much more robust the Gen AI process is in comparison. The generative AI process can take training code, labels data, and unlabeled data of all kind of data and build a foundational model. The foundational model can then generate new content. It can generate text, code, images, audio, videos, and many more. We have come a long way from traditional programming to neural networks to generative models. In traditional programming, we used to have some hard codes, the rules for distinguishing a cat type animal, legs 4, ears 2, fur, yes, likes yawn, these kind of things. But it dislikes red because it's a dog. In the wave of neural networks, we could give the network pictures of cats and dogs and ask, is this a cat? And it would predict a cat or not a dog. What's really cool is that in the generative wave, we as users can generate our own content whether it be text, videos, audios, or more. For example, models like Gemini, Google's multi-model AI system, or Lambda, language model for dialogue applications, ingest very large data from multiple sources across the internet and build foundation language models we can use simply by asking a question, whether typing it into a prompt or verbally talking into the prompt itself. So when you ask it, what is a cat? It can guide you everything it has learned about cat. Now, let's make things a little more formal with an official definition. What is generative AI? Gen AI is a type of artificial intelligence that creates new content based on what it has learned from existing content. The process of learning from existing content is called as training and results in the creation of a statistical model when given a prompt. Gen AI uses this statistical model to predict what an expected response might be, and this generates new content. It learns the underlying structure of the data and can then generate new samples that are similar to the data it was trained on. Like I mentioned earlier, a generative language model can take what it has learned from the examples it is shown and create something entirely new based on that information. That's why we use the word generative. But large language models, which generate novel combinations of text in the form of natural sounding language, it is a huge system, are only one type of generative AI. A generative image model takes an image as input and can output text and any other image or video. For example, under the output text, you can get visual questions and answering. It takes text as input and can output more text, an image, audio, or any decisions which you made. For example, under the output text, question and answering is generated, and under output, image, a video, or anything which you want. I mentioned that generative language models learn about patterns in the language through training data. Check out this example. Based on things learned from its training data, it offers predictions of how to complete this data. I am making a sandwich with peanut butter and jelly. Pretty simple, right? So, given some text, it can predict what comes next. This generative language model are pattern watching systems, like they follow a specific pattern. They learn about patterns based on the data you provide. Here is the same example using Gemini, which is trained on a massive amount of text data and is able to communicate and generate human like text in response to a wide range of prompts and questions. See how detailed the response can be. Here is another example that's just a little more complicated than peanut butter and jelly. Sandwiches, because making a sandwich is not a big deal. The meaning of life is, and even with a more ambiguous question, Gemini gives you a contextual answer and then shows the highest probability response. The power of generative AI comes from the use of transformers. Transformers produced the 2018 revolution in natural language processing. At a high level, a transformer model consists of an encoder and a decoder. Basically, the encoder encodes the input sequence and passes it to the decoder. which learns how to decode the representations for a relevant task. Sometimes Transformers runs into issues through hallucinations are basically words or phrases that are generated by the model that are often nonsensical or grammatically they are incorrect. See, not great. Like hallucinations can be caused by a number of factors, like when the model is not trained enough for the provided data, is trained on noisy or dirty data, is not given enough context, or is not given enough constraints that he understands whatever is asked. Hallucinations can be a problem for transformers because they can make the output text difficult to understand. They can also make the model more likely to generate incorrect or misleading information. So, put simply, hallucinations are bad. Let's pivot slightly and talk about prompts. A prompt is a short piece of text that is given to a large model which works on that text and provides you your desired results. Okay? So it basically controls the output of a model in a variety of ways. There are various ways, such as prompt design is a process of creating prompt that will generate the desired output. From an LLM, it is also a device. Like I mentioned earlier, generative AI depends a lot on the training data that you have fed into it. It analyzes the patterns and the structures of the input data and thus learns from the pre existing data. But with access to a browser based prompt, you, the user, can generate your own content as you desire. So let's talk a little bit about the model types available to us when text is our input and how they can be helpful in solving real world problems like never being able to understand my friends when they talk about soccer. I don't know that what soccer is. So basically, the first thing is text to text. Text to text models take a natural language input and produces text output. These models are trained to learn the mapping between a pair of text. Like you provided the text that I don't understand a soccer game. So they'll provide you the solution by understanding the text which you provided and then they analyzed it and asked you accordingly. So basically this is text to text. And talking about text to image, you provided a text and then they generated the image on the basis of your idea. Okay, so this will be shown further. So what is diffusion? It is also one of the methods used to achieve text to video or text to 3D models aim to generate a video representation from text input. The input can be anything from a single sentence to a full script and the output is a video that corresponds to the input text. So simply, text to 3D models generate three-dimensional objects that corresponds to a user's text. So this is the all. Hope so you guys learned it very well and enjoyed a lot. Moving further, there is the playlist for you which you guys can see later. Bye bye. It's all for now.